So how did a company that got its start making graphics cards for video games end up at the very center of the AI revolution? Well, it's a pretty incredible story about a single, powerful idea that took about 30 years to really pay off, and now it's changing everything. So let's dive in.
Listen to this vision from NVIDIA CEO Jensen Huang. He's not just talking about self-driving cars or those arms in a factory. He means everything that moves. It sounds like something straight out of science fiction, but the technology to make it a reality, it's being built as we speak.
Okay, but really, how in the world do you connect the dots from pixelated video games to a future filled with intelligent robots? It's not an obvious path, right? But it all started with a very specific problem that game developers were running into way back in the 90s.
All right, to really get this, we've got to go back to the very beginning. We need to understand the core insight that honestly changed everything.
So back in the 90s, you had these game developers with huge dreams. They wanted to build these incredible, immersive, 3D virtual worlds. But there was one massive problem. The computers back then just couldn't hang. The math it took to render all those graphics was completely overwhelming the hardware. They had hit a wall.
And this is where NVIDIA's big idea comes in. They realized that computers didn't need one brand. They needed two different kinds of brands. You've got your standard CPU, the central processing unit. Think of it like a single super smart expert, solving really tough problems one after another. But a GPU, a graphics processing unit, that's like a whole army of workers, all tackling thousands of smaller, simpler tasks at the exact same time. It's called parallel processing.
Okay, here's a great way to think about it. Kind of like a Mythbusters experiment. The CPU? That's one robot, methodically firing one paintball at a time. Bang, bang, bang. But the GPU, oh, that's a whole different beast. It's this massive machine that just unleashes thousands of paintballs all at once. That's the difference. That's the power of parallel processing.
Jensen Huang actually calls the GPU a time machine. And the reason why is pretty amazing. You see, this incredible speedup lets scientists run these super complex simulations, stuff that would have taken them their entire career to figure out. All of a sudden, a lifetime of work could be done in just a couple of years. It lets us see the future of science and discovery way sooner.
So you've got this unbelievable power, right? But for a while, it was basically locked away in the world of gaming. The next giant leap was figuring out how to hand the keys to everybody else.
I love this part. In the early days, it was so wild. If you were a scientist, say studying quantum chemistry, and you wanted to tap into that GPU power, you literally had to trick it. You had to make your molecular simulations look like a video game to get the hardware to even notice them. It's a brilliant hack, but yeah, not exactly a long-term solution.
So this kicked off this incredible chain reaction. First, you have the problem, access. Researchers couldn't get to the power. So what does NVIDIA do? They build the solution, a platform called CUDA, which made programming these GPUs super simple for anyone. And the result? Suddenly, researchers everywhere had the power of a supercomputer sitting on their desk. And that accessibility, that was the spark that lit the fuse for a totally new way of thinking about AI.
Now you got to understand, this was not an overnight thing, not even close. NVIDIA poured billions into creating CUDA for what Jensen Huang calls 10 long years. That is a massive bet on the future. They were basically saying, if we build this, we believe the innovators will show up. And you know what? They did. In 2012, an AI model called AlexNet, trained on their GPUs, just shattered all the records in an image recognition competition. That was the moment. The bet paid off, and it laid the foundation for the entire AI world we live in today.
And this unlocked a fundamental, seismic shift in how we compute. Think about it. For like 60 years, programming was all about giving computers step-by-step instructions. But now, with the insane parallel power of GPUs, we can do something totally different. We can just show them millions of examples, of pictures, of words, of data, and let them learn on their own. We went from instructing to training.
Okay, so we have this brand new foundation, right? We're training computers instead of instructing them. So what's the next big frontier? Well, it's taking that idea and applying it to the physical world. Yep, we're talking about robots.
But here's the thing about robots. Training them in the real world, it's kind of a nightmare. It's super slow, you're constantly worried about breaking expensive gear, and how can you possibly prepare them for every single weird, rare, or dangerous thing that could happen out there? So what's the solution? Jensen Huang has this fantastic analogy that just clicks. You know how with a language AI like ChatGPT, you ground it in facts? You give it a PDF for search results so it doesn't just make stuff up? Well, you do the exact same thing for a robot. You ground its AI brain in a physics simulator.
this virtual world called Omniverse, where the laws of physics are the absolute truth. And that's how you give a robot physical common sense.
And the benefits here are just staggering. I mean, think about it. Inside these simulations, a robot can experience millions of scenarios in the time it takes us to drink our coffee. They can safely practice for dangerous emergencies or rare factory malfunctions over and over and over again without a single scratch or dent. This is what people are calling the Big Bang moment for robots.
Okay, so this all sounds huge, right? Robots and virtual worlds. It's a lot, but what does any of this actually mean for you and me in our everyday lives?
And that really is the million-dollar question, isn't it? With this kind of power becoming accessible to basically everyone, how is it going to change how we work, how we learn, how we create?
Here's another great way to picture it. When they built the interstate highway system, the goal wasn't just to make it faster to ride your horse from one town to the next, right? No, it created entirely new things that nobody even saw coming. Suburbs, nationwide shipping, fast food chains, motels, the whole economy changed. That's what this AI revolution is. It's not just an upgrade, it's a completely new foundation.
So how does that translate down to us, personally? According to Jensen Huang, the biggest change is that the barriers to just understanding things are coming down. I mean, for the first time ever, every single one of us can have a personal tutor with us 24/7, ready to explain any topic, teach any skill, or help us think through any problem we have.
So you see, the big takeaway here isn't that we're going to be replaced, not at all. It's about being empowered. It's like how a calculator doesn't replace an accountant, it makes them better at their job. We're going to become, well, kind of superhuman, because we'll have these super AIs right there with us, helping us out.
And that really brings us to one last big question, a question for you. For decades, what we could build, what we could dream up, was always capped by how much computing power we had. Well, that cap is disappearing. It's vanishing. So, if this technology is making the impossible possible, what are you going to build?